A single rack of servers on Earth can consume as much electricity as a small town. Millions of them are running right now, hidden inside unmarked buildings, powering the apps we open without thinking. The AI models we ask to think for us. Most people assume data centers have to stay on Earth. They need power, cooling, and human hands to maintain them, so naturally they sit in deserts, farmlands, and cold northern cities. But that assumption is starting to crack. Some researchers are now asking a strange question. What if the next frontier for AI isn't underground or underwater, but in orbit? And what if the company photographing our entire planet every single day is about to train an AI on every pixel of Earth? This is the story of two impossible ideas colliding: data centers in space and something called large Earth models. Here's the part that should stop you. The next big leap in AI might not be a new chip. It might be a new address: low Earth orbit. It sounds like science fiction, but the physics is quietly seductive. In the shade of orbit, temperatures plunge toward the cold of deep space, and the sun above the atmosphere shines hour after hour, with no clouds, no seasons, no night. The very things that make space feel impossible, the emptiness, the silence, the cold, might be exactly what a planet overheating from computation needs. What if the ultimate cooling solution isn't a better fan? What if it's leaving Earth entirely? But why would anyone even consider launching a data center into orbit? To understand that, we need to talk about heat. Every time a server processes data, it generates heat. That heat has to go somewhere. On Earth, we cool data centers with massive air conditioning systems, water cooling loops, and increasingly, entire buildings designed to channel heat away. But this cooling infrastructure is expensive, consumes enormous amounts of energy, and is one of the biggest reasons data centers are so power hungry. Now, imagine a place where the background temperature is just a few degrees above absolute zero. A place where there's no air to trap heat, only the cold vacuum of space. The idea seems almost too perfect. In fact, the European Space Agency has studied the concept of orbital data centers as a theoretical solution to Earth's growing energy and cooling problems. These are real proposals, though they remain largely on the drawing board. The physics, in theory, is simple. In space, you can radiate heat directly into the void, no air conditioning required. But if space is so cold, why haven't we already moved our servers there? The answer is that getting anything into orbit is extraordinarily expensive. Launching a single kilogram of payload can cost thousands of dollars, and a data center weighs tons. Then there's the problem of maintenance. If a server fails in a data center on Earth, a technician can walk over and fix it in minutes. In space, a repair mission would require a rocket, a spaceship, and a team of astronauts, if it's even possible at all. And then there's the issue of latency, the time it takes for data to travel between the user and the server. A data center in low Earth orbit might be a few hundred kilometers away, but the signal has to travel up and back down, adding milliseconds of delay. For many applications, that's unacceptable. So, the physics of cooling might point to space, but the economics and engineering realities keep us grounded. Yet, the idea refuses to die, because as AI grows, so does our demand for computing power, and so does the heat. And on Earth, we're running out of easy solutions. Some researchers suggest that space might not be the answer for everything, but for the most intensive, heat-generating computations. It could be the only place left to go. So the question remains, if space is so cold, why haven't we already moved our servers there? The answer is complicated, but as we'll see, some of the world's most ambitious companies are starting to think. The obstacles might not be as insurmountable as they once seemed, but there's one name that keeps coming up in this conversation, and it's SpaceX. Its founder, Elon Musk, has dropped hints that are too big to ignore. In interviews and offhand remarks, Musk has suggested that the future of AI computing might not be on Earth at all. It could be in orbit, riding aboard the very rockets that are already ferrying satellites and astronauts into space. Now, this isn't a confirmed plan. There's no official blueprint sitting on a desk at SpaceX headquarters, but the idea has a certain gravitational pull. Think about it. In space, the sun never sets. Solar panels could collect energy around the clock, without clouds, without weather, without the planet's rotation turning off the lights every night. On Earth, a data center has to compete for power on a grid that's already strained. In space, the energy is just there, endless, clean, and free, at least in theory. That's the dream. But here's the catch, and it's a big one. The same thing that makes space so attractive, the cold, the vacuum, the silence, is also what makes it brutally hostile to the delicate machinery inside a server. Heat dissipation, the simple act of getting rid of the warmth that every processor generates, becomes a nightmare in zero gravity. On Earth, you can pump water, blow air, or just open a window. In space, there's no air to blow, no water to pump. The only way to shed heat is through radiation, and that's slow, inefficient, and requires massive radiator panels. Some engineers call it the killer problem. It's the reason why, despite decades of research, no one has actually built an orbital data center yet. But the pieces are starting to fall into place. SpaceX's Starship, the most powerful rocket ever built, could theoretically lift entire server racks into orbit in a single launch. That's a game changer. A few years ago, the cost of putting a single kilogram into space was astronomical. Now, with reusable rockets, it's dropping fast. And as the cost falls, the idea of a data center in orbit becomes less like science fiction and more like an engineering challenge. There's also a financial angle here that's hard to ignore. When Elon Musk sat down with JP Morgan's Jamie Dimon in a recent interview, the conversation touched on the intersection of AI, energy, and infrastructure. It's a reminder that the people with the deepest pockets are already thinking about where the next generation of computing will live. They're not just asking if we can do it, they're asking if we can afford not to. So, what's the real killer problem? It's not the rockets, it's not the solar panels, it's the heat. And until someone cracks that, the billion-dollar bet on orbital AI remains just that, a bet. But as we'll see, there's another player in this story who's already looking down at Earth from space. They have a very different idea about what AI should be watching. That player is Planet Labs. While SpaceX dreams of computing in orbit, this company is already looking down from space, not at the stars, but at our own planet. Planet Labs operates a fleet of satellites that photograph the entire Earth every single day. That's not a metaphor. Their constellation captures images of every corner of the globe, from the changing colors of the Amazon to the slow creep of glaciers in the Arctic. And now, its CEO, Will Marshall, is talking about something called a large Earth model. It's a phrase that sounds carefully engineered, but its implications are enormous. The idea is to take all that continuous daily imagery of our planet and feed it into an AI system, not just to map coastlines or track storms, but to train a model that understands the Earth as a whole, a living, breathing system. Imagine an AI that has watched every field, every forest, every city, every day for years. It would notice patterns that human eyes have missed, subtle changes that precede a drought, a crop failure, or even a conflict. This is the promise of a large Earth model, a digital twin of our planet that can help us predict the future, not with magic, but with data. And here's where it connects to the story of data centers, because a model like this doesn't just need data, it needs compute, enormous planet-scale compute. To train an AI on the entire Earth's surface, day after day, you need processing power that dwarfs what most companies use today. And so the question becomes, where does that compute live? On Earth, where it consumes energy and produces heat? Or in space, where the sun never sets and the heat can be radiated away into the void? Planet Labs itself doesn't build data centers, at least not yet. But the data it collects is a perfect example of the kind of problem that might push us toward orbital computing. The sheer volume of imagery is staggering, and transmitting all of it back to Earth for processing creates a bottleneck. What if, instead, some of that processing happened in orbit, right next to the satellites? A space-based data center could receive the raw data, run the AI models, and only send back the insights, the answers, not the terabytes of pixels. This is still speculative, a concept discussed by researchers and engineers, not a working system. But it shows how the two threads of this story are beginning to weave together. The need for massive compute is growing, and the need to understand our planet is growing just as fast, and both might find their solution in the cold, silent vacuum above us. So, if we can see the whole Earth every day, what could an AI learn that we've never noticed? That's the question Planet Labs is starting to ask, and the answer might not come from a server farm in Nevada, but from a satellite the size of a shoebox, orbiting hundreds of miles above our heads. But there is another layer to this story, and it's the one that connects both halves of what we've been exploring. Because the AI boom is not clean. We've all heard about the massive power draw of data centers, the water used for cooling, the land cleared for new facilities. But some of the more uncomfortable costs have only recently started surfacing in public conversations. Local power grids struggling under the weight of a single new facility, water restrictions introduced in areas where server farms need to stay cool, and the quiet tension between communities and the anonymous buildings that have moved in beside them. Documentaries have begun asking a tougher question. What don't AI data centers want us to see? The obvious answers are energy, water, land. But the deeper answer might be that our entire model of computing is reaching its physical limits. And that is exactly why space is starting to look less like science fiction and more like an engineering challenge. The vacuum around Earth is cold, nearly empty, and solar energy is constant. No nighttime, no clouds, no neighbors. The catch is that no one has built an orbital data center yet. This is still a concept, a vision, something being sketched in engineering papers and discussed in conference rooms. But the momentum is real enough that it has started to merge with another idea that sounds like it belongs in a different movie. An AI that watches the entire Earth every single day. Planet Labs is already generating an almost unimaginable stream of images from orbit. Its satellites photograph the whole land surface of the planet daily. The question is what to do with all that light. And the answer, according to its CEO, Will Marshall, is something called a large Earth model, an AI trained not on internet text, but on the changing surface of the Earth itself. It could recognize patterns invisible to the human eye. It could see crops under stress before the leaves change color. It could watch coastlines retreat, forests thin, cities sprawl, disaster zones unfold in real time. Training a model that large requires enormous amounts of compute. And that compute, for now, lives in the same data centers we just talked about. Which brings us to the spillover. What if that AI never has to come home? Picture this. A constellation of satellites captures images of Earth. A few hundred miles away, a space-based data center, powered by the sun, cooled by the vacuum, processes those images. The AI learns the planet's patterns in orbit and beams only the answers back down to Earth. No massive files crossing the globe through fiber optic cables, no grid power drawn for each training run, no precious fresh water used for cooling, just the final insight, arriving in seconds. This is a vision, not a product. No company has announced a timeline for building it. But it is the kind of idea that explains why orbital computing has quietly shifted from fringe conversation to boardroom speculation. And the future, if it ever arrives, probably won't be about moving every data center into space. It will be about moving the ones that matter most, the ones processing planetary scale questions, the ones where the distance between the sensor and the processor is already measured in orbit. What if the most important data never has to come back to Earth? That is the question now hanging over the entire conversation. Because if you can watch the whole planet every day, the value of processing that data in orbit isn't about escaping Earth. It's about seeing it clearly enough to act. And maybe, for the first time, the answer to our planet's biggest problems won't come from a server buried in a warehouse. It will come from above. But before we get swept away by the vision, let's pause. Because the road to orbital data centers is littered with obstacles that make even the most ambitious engineers hesitate. Space debris, for one. Every satellite, every spent rocket stage, every shattered fragment, they all share the same highways above us. A single collision could disable an entire constellation, turning a multi-billion-dollar investment into a cloud of shrapnel. Then there's radiation. Earth's atmosphere shields us from the sun's fury, but in orbit, that protection is gone. Solar flares and cosmic rays can corrupt memory, fry circuits, and force constant reboots. A nightmare for systems designed to run without human hands for years. And when something does break, there's no repair technician on call. Sending a crew to fix a server rack would cost more than the rack itself, and that's if the mission is even possible. But the quietest killer might be heat itself. In a vacuum, there's no air to carry heat away. Radiators must glow red hot to shed thermal energy, and in microgravity, cooling fluids behave in unpredictable ways. Some researchers suggest the very physics that makes space so cold may also make it nearly impossible to cool a dense cluster of processors. And the cost? Launching a single kilogram into orbit can run thousands of dollars. A full data center would weigh hundreds of tons. The price tag isn't just astronomical, it's beyond what most nations could afford. So why are some of the world's smartest people still chasing this? Because the payoff, unlimited solar power, near-perfect cooling, and a front-row seat to the planet's data, might be worth every risk. And sometimes, the biggest breakthroughs come from the problems everyone else says are impossible. As we look up at the night sky, it's easy to think of space as empty, silent, and unchanging. But the next generation of computing might see it as the most valuable real estate in the solar system. The same cold vacuum that once felt like a barrier could become the ultimate cooling system for the machines that will shape our future. And the same satellites that watch over our planet could one day host the intelligence that helps us understand it. This is still a story being written, with more questions than answers, more theories than certainties. But one thing is clear: the next big leap in AI might not be a new chip, it might be a new address. And if that day comes, the servers that hold our digital world will be looking down on us, not up from a warehouse floor. If this glimpse of the future sparked your curiosity, consider subscribing and joining us for the next episode, where we'll keep following the trail of the impossible ideas that are quietly becoming real. If you want the next clue in this pattern, subscribe and keep watching the series.